You can't see it, but it's pressing on you from every direction. At sea level, this invisible force weighs down with over 14 pounds per square inch, enough pressure to crush you if it weren't perfectly balanced by the air inside your body. It's the atmosphere, a vast ocean of gas swirling around our planet, and at the heart of understanding how it behaves lies a simple, elegant device: the barometer. From sailors navigating through deadly squalls to meteorologists issuing early storm warnings, the barometer has long served as a silent sentinel of the skies. It doesn't flash or beep or chime. Instead, it quietly measures atmospheric pressure, the subtle yet powerful shifts in air weight that precede nearly every change in weather. What makes the barometer so captivating isn't just its function, though that alone is profound. It's how it reveals the unseen world above us. A drop in pressure might signal a brewing thunderstorm or an approaching cold front. A rise in pressure often means clear skies and calm conditions. These changes may be imperceptible to our senses, but to a barometer, they're a clear and quantifiable message from the atmosphere. The barometer's invention in the 17th century wasn't just a scientific achievement. It was a paradigm shift. Before Evangelista Torricelli filled a glass tube with mercury and inverted it into a basin, no one truly understood that air had weight. His breakthrough gave humanity a tool to read the mood of the sky. No longer did we rely solely on folklore or intuition to guess what tomorrow might bring. We now had physics on our side. Today, barometers come in many forms. From ornate, antique aneroid dials mounted in wooden cases to sleek digital sensors embedded in smartphones and smartwatches, the principle remains the same: track pressure, and you can predict the future, at least in weather terms. But the barometer is more than a forecasting tool. It's a reminder of nature's quiet cues, how even the most subtle changes in our environment can have massive consequences. A fast-falling pressure reading might precede a life-threatening cyclone. A steady high-pressure dome might trap pollutants in a city, causing dangerous air quality levels. The barometer warns us, but it also teaches us to listen. Whether used by hikers in the Andes, airline pilots cruising at 35,000 feet, or coastal farmers trying to protect their crops from unexpected rain, the barometer is universal in its utility. It speaks a language understood by both analog dials and cloud-connected apps. A language that begins and ends with pressure. In a world obsessed with flashy innovation, the barometer stands as a timeless example of scientific simplicity with extraordinary impact. It doesn't try to impress. It doesn't need to. All it does is reveal what the sky is about to say. A barometer is a scientific instrument used to measure atmospheric pressure, the force exerted by the weight of the air in the Earth's atmosphere. Since atmospheric pressure is a key factor in weather formation, barometers are fundamental tools in meteorology, aviation, and oceanography. Atmospheric pressure is not constant. It fluctuates due to factors like altitude, temperature, and air movement. A barometer quantifies these fluctuations and expresses them in units such as inches or millimeters of mercury, in Hg or mmHg, millibars MB, hectopascals, HPA, standard in modern meteorology. By continuously monitoring pressure, a barometer helps detect subtle shifts in weather systems. Mercury barometer, invented by Evangelista Torricelli in 1643, uses a glass tube filled with mercury, inverted into a basin. Air pressure pushes on the mercury in the basin, raising or lowering the column in the tube. Still highly accurate, but toxic mercury and fragile glass make it less common today. Aneroid barometer contains a sealed, flexible metal chamber, aneroid cell. As pressure changes, the chamber contracts or expands. Mechanical levers translate movement into a readable dial. Compact and mercury-free, ideal for homes, ships, and aircraft. Small blue diamond digital barometer uses electronic sensors to detect pressure changes. Often built into smartphones, smartwatches, and weather stations. Provides real-time readings, trends, and integration with GPS and forecasting software. Barometric pressure is one of the most reliable short-term indicators of changing weather. Here's how different trends in pressure relate to atmospheric conditions. White heavy checkmark high pressure, rising barometer, indicates stable, clear weather. Air is sinking and dispersing clouds, associated with fair skies, low humidity, and little wind. Warning, low pressure, falling barometer, signals stormy or unsettled weather ahead. Air rises, cools, and forms clouds and precipitation. Rapid drops can mean incoming thunderstorms, cyclones, or cold fronts. Light bulb steady pressure suggests little to no change in weather. Often means the current weather will persist for the next 12 to 24 hours. Meteorology. Barometers are part of automated weather stations, radiosondes, weather balloons, and satellites. They help forecasters predict fronts, cyclones, and pressure systems. Aviation. Pilots rely on barometers, altimeters, to measure altitude and anticipate turbulence caused by pressure changes. Maritime navigation. Sailors and fishermen use barometers to anticipate storms and rough seas, especially vital in open waters. Hiking and mountaineering. Portable barometers, or barometric altimeters, estimate elevation and help track weather in remote locations. On weather maps, atmospheric pressure is shown using isobars, lines connecting points of equal pressure. Closely spaced isobars, strong winds and fast-moving systems. Widely spaced isobars, calm, stable weather. Meteorologists track high pressure, H, and low pressure, L, centers to anticipate movements of weather systems. While barometers are essential, they don't predict specific events, only trends. For example, a falling barometer signals a storm may come, not when or how severe. Local anomalies, e.g., mountain ranges or urban heat islands, can distort readings. Thus, barometers are used with other data, such as satellite imagery, humidity, and temperature trends, to improve accuracy. You can make a simple barometer at home using a sealed jar, a straw, balloon membrane, rubber band. As air pressure changes, the balloon surface bends, and the straw moves, showing pressure changes visually.